Hello friends, today we will learn protection of transmission line. Okay, so what is the which topics is related with the transmission line protection? First, overcurrent protection of all the feeder using the directional and non-directional overcurrent relay. Then introduction to the distance protection, impedance relay, reactance relay, Moore relay. This relay is related with the distance protection. Then introduction to PLCC with the block diagram, advantage and the disadvantage. Then three-step distance protection. It is also topic related with the distance protection. Then what is the effect of arc resistance and power swing on the performance of the distance relay? And last topic is realization of the distance relay using impedance, reactance, and the Moore relay using the numerical relay with the algorithm, flow chart, and the block diagram. And last topic is the wide area measurement system. Now the first question is, what is the transmission line protection? So this protection scheme, it is a very simple. Here the total line, it is divided into the different section, and each section is provided with the definite time relay. So the relay nearest to the end of the line has a minimum time setting, while time setting of other relays successively, it is increased and toward the source. So then which type of the transmission line, which type of protection it is used in the transmission line? So the main protection scheme, it is the distance protection scheme. So since the impedance of the transmission line can be directly proportional to the distance of the fault in the line, then it is due to the simple series model, and it helps in identify the fault location. So this type of protection, it is known as the distance protection, and this is also called as the under impedance protection. Then the transmission lines have a large length, and it is exposed to different atmospheric condition. So the chances of occurrence of the faults are more. So what are the different fault for the transmission line? So the transmission line, that means the overhead line, which type of fault occur in the system. Similarly, the feeder lines and the transmission line are of the much bigger, that means the uh, it is nothing but there is the length, then 100 of kilometers, and these are exposed to the atmosphere. So there are the chances of occurring of the faults due to the windstorms, then ice flashover, then lightning falling trees, then objects bird, dirt, dust, and etc. So faults may be short circuited, open circuited, and earth fault lightning also. So the requirement of the transmission line protection scheme are, which type of requirement of the transmission line protection schemes are? If the circuit breaker is nearest to the fault and fails to open, the backup protection circuit breaker should operate. That means the protection zones of protection, it is nothing but backup protection is there, relay protection is there, and the remote protection is there. When the circuit breaker is nearest to the fault and fails to open, the backup protection circuit breaker should operate. Then the event of the short circuit in any section, that means suppose this is the line and the short circuit occur in the system. Okay, in the event of the short circuit in any section the short circuit is occur. So the circuit breaker is here. Suppose this is one circuit breaker, this is two circuit breaker, and this is three circuit breaker, and then the fault occur in the system. Suppose this is the fault. So in that condition, the circuit breaker is closest to the fault, that should be open. So this circuit breaker, that means this is the A, this is the B, and this is the C circuit breaker, and the fault occur in between the B and the C point. So which circuit breaker is nearest to the fault? Okay, which circuit breaker is nearest to the fault? So the circuit breaker is closest to that fault should open, and other circuit breaker should be in the closed position. That means this C circuit breaker, it will be the open because it is nearest to the fault. If the circuit breaker is nearest to the fault and fails to open, suppose fault occur in this nearest to the C section, C circuit breaker, and it will be fails to the fault, it will be fails to open. So the backup protection circuit breaker should operate. That means this is nothing but this is the backup protection of the circuit breaker. So it will be the operate. So the relay operating time should be as short as the possible. So we have to set here the relay time, circuit breaker time. So this is nothing but the setting of the relay time, setting of the circuit breaker as per the we can use with the differential protection scheme can satisfy above condition. So this all the backup protection it will be satisfied in the differential protection scheme. So the transmission line can be divided into the number of section. Number of section that means 20 kilometer, 30 kilometer, 40 kilometer is like that. So depending upon the line classification, that means the distribution line, subtransmission line, transmission line, high voltage, extra high voltage, and the ultra high voltage. So this is the range for the line classification. So according to the transmission line can be divided into the number of the section. So each section can be protected by the differential protection scheme. But since length of the transmission line is large, but the length of the transmission line is large, so this scheme becomes uneconomical. So so the following methods are used. Following methods are used, that means uh, following methods are used, that means just wait. Following methods are, that means this transmission line protection, there are the four methods. Okay, first is the distance protection, then differential protection, then overcurrent protection. So this type of protection are classified. So first is the current protection, current gradient system, then time graded overcurrent protection, then differential pilot wire protection, and last one is the distance protection. Last one is the distance protection. So this time graded overcurrent protection again classified into the three types: parallel feeder, radial feeder, and ring main system. Then similarly for the differential pilot wire protection, Merz price voltage balance system and Transley system. So time graded overcurrent, that means it is the applications. That means the feeder, different type of feeders are there: radial feeder, parallel feeder, and the ring main system. So according to this application of the feeder, the time graded overcurrent protection is applicable, and the magnitude is the current. Okay, the magnitude is the current. Then the second is the differential protection, differential pilot wire protection. So it is basically classified into the two types: Merz price voltage balance system, and second is the Transley system. So first we will see the current graded system. So what is the current graded system? Current graded system, it is nothing but the it is a alternative to the time grading or in addition to time grading. That means the current grading principle can be applied when the impedance between the two substation is satisfied. When the two substation is the satisfied. That means this type of the protection is based on the current grading. So it can be used along with the time grading, but if only the current grading protection is to be used, the impedance between the two substations should be the sufficiently large system is there. Then it uses the high speed overcurrent relay. It uses the high speed overcurrent relay. Then the short circuit current along with the length of the protected circuit breaker decreases, and circuit decreases with increase in the distance between the supply in and other fault point. So it means when the length of the line is increases, when the length of the line increases, that means the transmission line increases. So the impedance is also increases and the current level is decreases. This is the meaning of the short circuit current along the length of the protected circuit is decreases with increase in the distance between supply end and the fault point. Then the next is, if the relay are said to operate the higher current towards the supply end, and then the drawback of the long time delays occurring in the time graded system can be partially overcome. So this is known as the current grading system. So there is the here shows the current graded principle using overcurrent relay. This current graded principle, it is using overcurrent relay. So feeder, it is divided into the three sections: section A, section B, and the section C. So on then overcurrent relay with prospective pickup values are installed in section. All the prospective values or the respective values, pickup values, that means all the respective pickup values are installed in each section. Section A, section B, section C. With the CT secondary, that means it is nothing but it is connected with the relay coil. Okay. This A, B, C, it is nothing but the sections. In between, this is nothing but the circuit breaker, and CT secondary, it is connected with the relay coil. So this is the relay setting. That means the relay current setting. So this is the pickup value. This is called as the pickup value. Now the next is if the relay, that means the figure shows if the relay are set to operate at the progressively higher current towards the supply. That means higher current towards the supply side. That means it has a two section. This is the supply section and it will be connected to the load. So if the relay are set to operate the progressively higher current towards the supply, when the drawback of the long time delay occurring, the time graded system can be partially overcome. So this is called as the current grading system. So this this control graded current grading system employ the high speed set over current relay. Okay. So this current graded protection is applied to the radial feeder as shown in this figure. You can see here. Okay. So suppose the setting is such that, suppose we can set the such that, that means the value can be set that if the fault occur in the section A and B, suppose the fault occur in the section A and B. So relay A operate. Similarly, if the fault occur in the B and C section, if the fault occur B and C section, similarly. B and C section. So B operates. Circuit breaker B is operate. Now beyond C, if the fault occur, then relay C is operate. Here you can see the relay setting of the relay. It is a 12.5 ampere for the A. Then for the B, 10 ampere, and for the C, it is the 5 ampere, and so on. So here the current setting is decreases. Here the current setting is decreases progressively from supply end to load end. That means remote end of the line. So this is based on the fact that the short circuit current is decreases. The short circuit current is decreases with increasing distance. That means the short circuit current, this is nothing but the short circuit current, it will be decreases with increasing the distance between the supply end and the fault point. Now assume the fault occurring in the section B to C. Wait, I will clear this all the drawings. Yes. Now the fault occur. Now assume the fault occurring in the section B to C. Similarly, yes, B to C. What is expected? As it is occurring between the section B to C, the relay B should operate to isolate the faulty part. Now let us assume the second case. If the fault occurring in the section B to C, but now the location is very nearer to the station. Ideally, the relay B should operate and to isolate the faulty section because it is occurring in the B to C section. But in actual practice, the relay A feels that the fault it is in the AB section. And this is because very little difference in the fault current. And relay cannot discriminate whether it is occurring in the next second, or it is occurring in the end of the first second. Because because of this fault, because of this fault, the difference in the fault current value, that means the fault current value, if very small, because the fault current value is very small and magnitude of the fault current cannot decide very accurately. So the proper discrimination, the relay are said to protect only 80% of the line. 80% of the line. 80% of the line. And the relay are said to protect only 80% of the line. So instead of complete of the 100%, that means 100% line में से आपकी 80% line it will be the protected. For this reason, the current grading system protection can be employed alone, and it is always supplemented by the time graded system. So in the time graded system, there are some difficulties. That means the current grading becomes difficult because the difference in magnitude of the fault current is very, very low. It is very, very low. The current magnitude under the fault condition cannot accurately determine. I already told you. And in the transient condition, this is nothing but a transient condition. But in the transient condition, it is difficult to maintain the accuracy of the reading. So these are the difficulties in the current graded system. Now, the second topic is the current graded over current protection. So what is the time graded over current protection? So in this time current over graded protection, that means the line or the feeder are again divided into the number of section. Over current relay are provided for each other section. When occurrence of the fault in any section, the relay operates and give the trip signal to the circuit breaker, and the circuit breaker then opens and isolate the faulty part. This is the principle. This is the principle. This is the principle. But in the time graded system, that means there is the figure. Okay. This is the figure for the time grading system. So this figure can show the time graded system. It is the scheme of the overcurrent protection in which the time discrimination it is incorporated. In other words, that means the time setting of the relay is so graded, that is the event of the fault smallest possible system is isolated. Smallest possible system is isolated. Okay. So this total line is divided into the different section. This total line is divided into the different section. That means again generating station to the load end. That means this is the generating or the supply end, and this is the load end. Relay 1, relay 2, relay 3, relay 4 are set with the different time sections. And this is the substation. This is nothing but this is the circuit breaker are connected here. So here the application of the time graded system applied to the radial feeder. Okay, this time graded it is used for the radial feeder. This is the application. So the main characteristic for the radial feeder, that means the power can flow only one direction. Power can flow. This is the power flow only the one direction. That means generator end or supply end to the load end. And it is desired that the smallest part of the system, this is the smallest part of the system, and it should be isolated in the case of the fault. So here the total line it is divided into the different section, and each section can provided with the definite time relay. So using the definite time relay, that means there are the different sections are there. So we can using the definite time relay for the radial feeder. We can use the overcurrent protection for using time grading principle. Yes. So it is achieved to objective. What is the objective? What is our objective? That means the smallest possible part. The smallest possible part should be isolated in the case of the fault occurrence. And to achieve the operating time of the relay, it is adjusted in order to fair end of the feeder. Okay. This is the fair end of the feeder. So entire feeder is sectionalized like Suppose this is the 1, this is the A, this is B, this is C. That means A to B, B to C, and C to D, like that. Now, the definite time relay are used for the individual section. So this is the definite time relay. Okay, this is the definite time relay are used individual sections which give strip signal to the respective circuit breaker. So this is nothing but your circuit breaker is there. Substation A, substation B, and substation C. So this is the circuit breaker. Now, the relay nearest to the end of the line has minimum time setting while time setting of other relay successively increase toward the source. That means the relay 1, this relay 1 is operating for the, this relay 1 is operating for the 2 second, relay 2 1.5, relay 3 1.2, and relay 4 0.8. Now you have to observe from relay 4. Okay. So relay 4 it is for the 0.8 second. Then for relay 3 1.2 second, the relay 2 1.5, and relay 1 2 second. And for it is nothing but, so the if the fault occur in between the C to D section, okay, the fault occur in between the C to D section, that section will be isolated in the 0.8 second and the circuit breaker section, substation C. Remaining relay will not operate because their operating time is higher, because this relay it is nearer to the fault occurrence. I will repeat again. Okay. The relay nearest to the end of the line. The relay is nearest to the end of the line has minimum time setting, while the time setting of the relay is successively increased toward the source. That means this time will be the increases toward the source. But when the fault occur nearest to the relay, that means the value, it is very, very smaller values there. So this relay will be the operate, but remaining relay will not operate because the time is very, very high. In the similar way, suppose if the fault occur in the system, if the relay 4 and the substation C, that means the circuit breaker C, it fails to operate even after the 0.8 second, then R3 is operate after 1.2 second and causing to open the circuit breaker B. So act as a backup protection. In this similar way for the relay 2, then again if the relay 2, that means relay 3, it will fails to operate in 1.2 second, then circuit breaker C will not circuit breaker B will not operate. But if it fails to the relay 2, so similarly apart from that time, that means it will play the part in the time, it will be show here 1.5 2 second. So after that, when the relay 3 is failed, then circuit breaker B also fails to operate, then relay 2 is operate after the 1.5 second. So this is the working principle for the radial feeder. If the feeder, then next is the what are the drawbacks for this radial feeder? If the feeder is having the large length, suppose if the feeder having a large length, or one and or more number of the sections are there. There are the number of more sections are there. In that case, the time supply side point is more. For our case, it will be the 2 second, and which is appreciable. If the fault say line to ground fault, if the fault say the line to ground fault, line to ground fault, if there is the fault occur in the system. In section nearer to the transformer, and this section is nearer to the transformer or source, in that case amount of the fault current will be the more, and in case amount of fault current will be the more. अभी क्या है यहाँ पे fault current ये maximum है. So it will be more because line impedance is less. Line impedance is less. That means Z will be the less. Fault current is maximum. Then the length of impedance will be the minimized. I already told you the short circuit current along the length of the line protected circuited it will be the decreases. That means length of the transmission line, it is increasing. So the impedance also increasing. And then the current is decreasing. So it is nothing but the principle. That means if the fault say to the line to ground fault occur in the section nearer to the transformer or the power source. In case of the amount of the fault current will be the more. The fault current will be the more because line impedance is less. So this system is not suitable for the ring main system or interconnected lines also. It is only suitable for the radial line supply end at one end only. Okay. So this is not suitable for the coordinate needs changes with the new connections. It is not suitable for the length of the long length of the line. It is not suitable. Then continuity supply cannot be maintained at the receiving at the end of the fault. So ideally operating time should be the less for the more amount of the fault current. And if the feeder having the large length, if the feeder having the large length and number of sections are more and number of sections are more, number of sections are more, in that condition it cannot be satisfied. So the time graded principle, it is applicable when there is the impedance between the substation is low and feeder length is less. That means in that condition only it will be the applicable. So one note for the this time graded system. In addition to relay operating time, the circuit breaker operating time should also be considered. And in most of the cases, it is necessary to the limit the maximum tripping time is the 2 seconds. Okay, this is the important point is there. So this is related with the radial feeder. Thank you.